welcome back to the lecture number 18 of chapter 7. In this lecture, we are going to solve some questions from the exercise 7.3, which are based on 5 congruency of triangle as we have studied, such as what are the congruency of triangle, such as SAS, SA, right, AS, SSS and RHS. So all the questions are from such congruency. So let us start with our first question. So the first question is, triangle ABC and triangle DBC are two isosceles triangles on same base BC. So there are two isosceles triangles, but they have the base BC. They have a same base BC. Suppose this is the base BC. Okay. Let us draw first triangle ABC. Suppose this is the first isosceles triangle ABC. Since it is given that it is an isosceles triangle, so AB is equal to AC. This is clear. And having same base BC and vertices A and D on the same side of BC. Since there are two triangles, one is ABC and other is, suppose we have taken in this side DBC. But what is given here? Here given that A and D vertex are on the same side. But if we are choosing this figure, then as you can see, this vertex and this vertex lie on the opposite side of BC. Okay, but we need they must lie on the same side of BC. Then how is the figure? The figure must be like this. D must be lie on this side. Why? Because both A vertex and D vertex are on the same side of base BC. Clear? So let us join B with D and C with D. And it is also given that DBC is also isosceles triangle. So DBC is also isosceles triangle. That means DB is equal to DC. Understood? This is clear now. If AD is extended to intersect BC at P, what is given? It is given A and D. So this is extended. Okay. So AD is extended such that it will meet BC at a point. What is the name of that point? That point is P. Okay. So the name of the point is P. So this is the figure that we have drawn, that we have concluded from the statement that is given in the question number 1. You have to first draw such figures like this after reading the question. So this is all about the figure. Now, what we have to prove? We have to show that 5 statements. First statement is triangle ABD. Triangle ABD. So this triangle is congruent to triangle ACD. We have to prove it. Next statement is triangle ABP. ABP is congruent to the triangle ACP. Clear? Third, AP bisect A. This is AP. Now we have to prove that AP bisect the angle A. This angle. It means we have to prove that AP is the angle bisector of A. AP bisect D. Similarly, also we have proved that this line also bisect D angle. So AP is the angle bisector of angle D. And last, that is AP is the perpendicular bisector of BC. AP is the perpendicular bisector of which line? BC line. Perpendicular bisector means what? Perpendicular means it must be 90 degree to this angle, to this line and to this line, and also bisect BC. It means this half is equal to this half. So such 5 statements we have to prove. Let us move with proof of the first statement and gradually we will prove every statement. Okay, so let's start with the first statement, that is triangle ABD is congruent to triangle ACD. Okay, so the first statement that you need to prove is triangle ABD is congruent to the triangle ACD. Okay, so let us prove it. So in order to prove it, we have to compare the two triangles, ABD triangle and ACD triangle. So between triangle ABD and triangle ACD. So first thing is, as you can see, AB line or AB side is equal to AC sides. Why? Because ABC is an isosceles triangle is given. So AB side of ABD triangle is equal to AC side of SCD triangle. So you can write AB is equal to SC. Okay? You can write the reason. ABC is isosceles triangle. Next condition, in ABD triangle, this side BD is equal to, in ACD triangle, this side CD. Symbolically, I have represented it. Why? Because BD is equal to CD, because BDC is an isosceles triangle. So BD is equal to DC. The reason is that BDC is isosceles triangle. Understood? Third condition is, as you can see, for the triangle ABD, AD is a side. Similarly, for the triangle ACD, AD is also a side. So AD is the common side to both the triangle. Okay? So AD is equal to AD, common side. So this stands for side, this stands for side, this stands for side. Hence, by SSS congruency, we can write that this triangle ABD is congruent to the triangle SCD. Hence, by SSS congruency, triangle ABD is congruent to the triangle SCD. Understood? Now it is proved. Because we need to prove the first statement, that is the triangle ABD is congruent to the triangle SCD. It is proved now. Proved 1. Okay? So next, moving to the second statement. Now let us prove the second statement, that is triangle ABP. Which triangle? ABP. This triangle is congruent to the triangle ACP. Okay? Here also we will prove another two statements, but later on. Now we prove this statement. Okay, so proof for the second statement. Okay, how we will prove that this triangle and this triangle are congruent? See, in the statement 1, what we have proved? In the statement 1, we have proved that ABD triangle is congruent to ACD triangle. Yes or no? Yes, we have proved it. Now, remind the theorem, axiom number 7.2. According to axiom 7.2, if two triangles are congruent, then their corresponding angles must be equal. Yes or no? Yes. So can we write this angle of triangle ABD is equal to this angle of triangle ACD? Because these two angles are corresponding to this triangle and these two triangles are congruent. Okay? So since triangle ABD is congruent to the triangle ACD, we have proved it. Okay? So we can write that this angle, which angle? This angle, BAD is equal to which triangle? This angle, CAD. Because these are the corresponding angle of congruent triangle by axiom 7.2. Do you understand it? Now, not only these two angles are equal, but also we can write that this angle of this triangle ABD is equal to this angle of the triangle ACD. Can we write it? Yes, we can write it, because they are also the corresponding parts or corresponding angle of a congruent triangle. So we can write, and ADB is equal to ADC. Don't be confused. We can write it or not? Yes, we can write it, because these are the corresponding parts of congruent triangle by axiom 7.2. Okay, so what we can conclude here? Since what we have found? We have found that BAD, this angle, is equal to CAD, this angle. It means what? This half is equal to this half. It means what? It means this total angle is bisected by this line AP. Yes or no? Again I am telling you, the total angle is divided into two equal halves. As we have found, this half is equal to this half. So it means AP bisect angle A. Okay? So from this we can conclude that means what? AP bisect which angle? Angle A. Do you get it? So actually this is the proof of third statement. See, AP bisect A. We have proved the third statement first before proving the second statement here. Okay. So literally you can write it as proof for the third statement. Because it is very easy, that's why I have solved it first. Okay. So we have proved that this angle and this angle are equal. So AP is the bisector of this angle A. Okay. So this is proof for the statement 3. Proved. Okay. So let us prove the fourth statement also. It is also very easy. See, if AP is a line, okay, if AP is a line, then DB is a ray on it. We consider which as a line, this as a line, and DB is a ray on it like this. Then how many angles formed here? This is an angle, this is also an angle. So how many angles are formed here? Two angles are formed, and these two angles are known as linear pair angles. Okay, so let us write it. Since AP is a line and DB stands on it. Okay, so we can write that there are two angles formed, this angle, and these two angles are known as linear pair angle, and we know the sum of linear pair angle is equal to 180 degree. So this angle plus this angle is equal to 180 degree. Okay, so this angle means ADB, or you can say BDA, whatever you can write. ADB plus this angle PDB, 180 degree. Did you get it? Suppose this is equation 1. Don't worry, it is very easy. Just cooperate me. It will solve very easily. Now, again consider AP as a line. AP is a line, and see, this stands on it. Yes or no? Yes. And this stands on it. Then how many angles formed here? See, this is the point D. Then this one first angle, this one the second angle. Then two angles formed here. Since these two angles lie on this line, this base, so these two angles are known as linear pair angle, and the sum of two linear pair angle is 180 degree. So this angle means ADC plus this angle, okay, means PDC is equal to 180 degree. This is equation 2. Okay, you know it. Now compare equation 1 and equation 2. What you see here? You see in equation 1 the right hand side is 180 degree. In equation 2 the right hand side is also 180 degree, isn't it? So let us compare these two equations. So by comparing these two equations, what we get? We get, after comparing equation 1 and 2, what we get? Since the right hand sides are equal, then we can write that their left hand side must be equal. So this one, ADB plus PDB is equal to this portion, ADC plus PDC. Right? Now, is it visible to you? Okay. Now, since it is given ADB is equal to ADC, yes or no? Yes. It is given ADB is equal to ADC by axiom 7.2. So we can write in the place of ADB, we can substitute ADC. In the place of ADB, we have substituted ADC plus PDB. Carefully look at it, carefully. Now this ADC must be taken to the left hand side, so that it will be minus ADC plus, is equal to PDC. Okay, here we have substituted ADC in the place of ADB, PDB. Then this ADC comes to the left hand side, it will be minus ADC is equal to PDC remaining. Okay, now this and this portion are equal, so they can be cancelled out. So what is left? The final result that is left is PDB is equal to what? PDC. Okay, what we have found? We have found PDB, that means this angle is equal to PDC, this angle. So this angle is equal to this angle. It means what? Tell me, it means what? This angle is equal to this angle. It means the total angle D is divided into two equal halves. This is the first half and this is the second half, and these two halves are equal. It means this line means DP or ADP or AP, because AP is a part of this line DP. See, if you can choose this as a line or you can choose this as a line. Okay. Since the total angle is divided into two equal halves, then we can write that DP is the angle bisector, or you can say AP is the angle bisector, because DP is also a part of AP. So DP or AP is the angle bisector of which angle? Angle D. Okay. So finally we can write, I think, yes, here we can write AP is the angle bisector of which angle? Angle D. Did you get this? Firstly, we have proved that AP is the angle bisector of angle A. How? Since we have found through exam 7.2 BAD angle, this angle is equal to CAD angle. We have found it by exam 7.2. It means this total angle is divided into two equal halves and two equal halves are equal. So AP is the angle bisector of angle A. Similarly, we have proved that this angle is equal to this angle. It means the total angle is divided into two equal halves. So AP is also the angle bisector of D, which is the proof for the statement 4. AP bisects D. So AP is the angle bisector of D. Okay. So this is proved for the fourth statement. Now let us prove the second statement. Okay. So till now we have proved three statements. That is, the first statement is triangle ABD is congruent to the triangle ACD. Then this statement, AP bisect A, this line AP bisect this angle. Okay, bisect this angle means what? It divides this angle into two equal halves. We have proved it. Then the fourth statement is AB bisects D. We have also proved that this AP bisects the angle D. That means it divides the angle into two equal halves. Okay. And now we will prove the second statement, that is triangle ABP is congruent to the triangle ACP. Okay. So let us prove for the second statement. For this we have to compare two triangles, triangle ABP and triangle ACP. So let us compare them. So between triangle ABP and triangle ACP, right? So here you can see in triangle ABP, in this triangle, this side AB, and in the triangle SCP, this side SC are equal. Why? Because ABC is an isosceles triangle and its two sides are equal. Because triangle ABC is isoscale. Understood? Next, in the triangle ABP, in this triangle, this angle is equal to, in this triangle, this angle. Because we have proved that AP is the angle bisector of the angle A, that means this half is equal to this half. Okay, so you can write angle BAP is equal to angle CAP SHAP is angle bisector of angle A. Understood? Then third condition is for the triangle ABP, AP is a side, and for the triangle ACP, AP is also another side. So AP is the side which is common to both the triangle. So the third condition is AP is equal to AP, common angle. So by S, this stands for S, this stands for angle, this stands for S. So by side, angle, side, angle, side, congruency, these two triangles must be congruent. Okay? Hence, by side angle side congruency, triangle ABP is congruent to the triangle ACP. Now it is proved. So we have proved the third statement. I think it is the second statement, not the third statement. So we have proved the second statement, that is triangle ABP is congruent to the triangle ACP. Okay? And finally moving to the last statement of the question, that is AP is the perpendicular bisector of BC. So we have to first understand the meaning of a term of perpendicular bisector. Okay? As we know, bisector means what? Bisector means it is a line which divides another line such that the two halves formed are equal. Okay? This is known as bisector. So a bisector always divides the line into two equal halves. So simply you have to prove that AP bisects BC. It means you have to prove that this half is equal to this half. PB is equal to PC. So ultimately we have to prove PB is equal to PC. Right? But there is another term which is known as perpendicular. What do you mean by perpendicular? I have told you. Perpendicular bisector means a line, suppose BC, and another line, suppose AD. Now AD is called as perpendicular bisector of BC if, first condition, it bisects BC. If it bisects BC, that means this half is equal to this half. The second condition is it must intersect BC, or it must intersect another line at an angle 90 degree. That is the meaning of perpendicular. Okay? So here you have to prove that AP bisect BC. That means PB is equal to PC, and also AP is perpendicular to this and perpendicular to this. Or you can say you have to prove AP is perpendicular to BC. So these two statements we have to prove. Or ultimately what we can write? We have to write that this angle means APB angle or APC angle is equal to 90 degree. So this thing we have to prove. So let's prove it. Okay. Proof for the fifth statement. Okay. Since in the second statement what we have proved? Since we have proved this triangle ABP is congruent to which triangle? Triangle ACP. So ABP is congruent to ACP triangle. Now, for considering this triangle ABP, PB is the side of this triangle ABP. Yes or no? Yes. If we consider ACP is another triangle, then PC is also a side of ACP triangle. Yes. But we know that this triangle is congruent to this triangle. So by axiom 7.2, if any two triangles are congruent, then their sides must be equal. So PB is equal to PC. Okay. So this is now due to axiom 7.2. So we have found that PB is equal to PC. It means this point divides BC into two equal halves. It means AP bisect BC. Okay, so this thing has been proved. PB is equal to PC. Okay, it means what? Implies AP bisects BC. Clear? Next, the second statement, that AP is perpendicular on BC, or this angle and this angle is 90 degrees. We have to prove it. How we can prove it? Let's see. If the triangle ABP and the triangle ACP are congruent, then can we write their corresponding angles are equal? Can we write it? Yes, we can write it. Since this angle is an angle for the triangle ABP and this angle is also an angle for the triangle ACP. So we can write that this angle APB is equal to this angle APC. We can write it. It is due to axiom 7.2. Clear? Now, BC is a what? BC is a line. Now, on this line, AP is a ray. Since BC is a line and AP stands on it. This is clear now. Okay. Now, how many angles formed? Two angles formed. BC is a line, AP stands on it. Then two angles formed, this angle, and these two angles are known as linear pair angle. And the sum of two linear pair angle is 180 degree. So, APB plus APC is equal to 180 degree. The reason is linear pair. Okay. And now, since what we have proved from the axiom 7.2, APB is equal to APC. We have proved it. So in the place of APB, we can substitute APC. Plus here also already APC is equal to 180 degree. The reason is that APB is equal to APC. This is clear. APC plus APC is 2 times APC is equal to 180 degree. Clear. Then what is the value of APC? 2 moves to the right hand side. It will be 180 degree by 2. Cancelled out 90 degree. Hence we found that APC is equal to 90 degree. So we have found that triangle APC, this angle is 90 degree. And what is the value of this angle? Since these two angles are equal, na? See, APB is equal to APC, na? So in the place of APC, we can substitute APB. So what is the value of APB also? So APB also 90 degree. So this angle is 90 degree and this angle also 90 degree. It means what? It means AP is perpendicular to BC. It means AP is perpendicular on BC. Previously we have found AP bisect BC. Now we have found AP is perpendicular on BC. So ultimately what we have found? We have found that AP is a perpendicular bisector of BC. Implies AP is a perpendicular bisector of BC. And finally, we have proved the fifth statement. Okay. So this thing you do not need to write. For your better understanding, I have written it. Okay. So finally, we have proved the fifth statement. Proved that AP is the perpendicular bisector of BC. Okay.